So let's, one of the skills we're going to have to work on today is decoding these problems. So let's talk about how we can do this. Generally, the best way to go about it is like one sentence at a time, even less if you can. Sometimes, like in our first sentence, you probably got to read the whole thing to make sense of what it means. But it says 2 security cameras are in a museum. They're adjusted to monitor a new display of fossils. The cameras are mounted 6 meters above the floor, directly across from each other on opposite walls. So we've already said a lot there. We want to look back now and see if we can, put some of this down on our page. The first thing I notice is it's got cameras that are 6 meters above the floor, and they're directly across from opposite walls. So that's what I'll draw now before I have to read any more into this. So here's my view of the room, and it says the cameras are directly opposite each other. So I'm going to say there's camera 1, there's camera 2, and it tells me they're 6 meters above the floor. So then all the stuff that I just read is just represented now in my picture, so there's a lot less for me to work with. We'll do the same thing as we keep going. We'll read it as shortly as we can, and then we'll add to the diagram. So it says the walls are 12 meters apart, which means this distance here in my picture is 12 meters. And there's a display case made of wood and glass. The top is at 1.5 meters above the floor. So we're going to put this display case somewhere in the floor. We don't know exactly where it is, but we can label some of the stuff here. It says the top is 1.5 meters above the floor. So I know that this height here is 1.5 meters. Then the distance from the camera on the left. So if you don't know your left from your right yet, that's okay. But anyways, that's this camera over here. To the center of the top display is 4.8 meters. So the center top is right there. And maybe I'll draw it in blue. The distance from that camera right to there is 4.8 meters. Sorry? You don't see any triangles. Yeah, there's none yet, but we're gonna have them pretty soon. And then it says both cameras must aim at the center of the top of the display. What is the angle of depression of each camera? All right. We're gonna work through this one, but first of all, one thing we should also put in here is if it's the angle of depression, it's the angle down. So if you go from here, this is the angle of depression. Elevation. So elevation is when the angle's rising. Depression if the angle is sad to be part of a trig problem. Well, I know you're listening. There's at least 3 people listening then. It's the angle of depression because it's falling. And it's part of a trig problem. All right, so what else can we put in? The first point was made is a pretty good one, is we don't know, there's no triangles here. Can anybody figure out a way we could add a triangle? Yeah. The second camera, so you're talking about the left or right camera? The right side to? Same point. Okay, yeah, we're going to definitely need that. And then straight across, okay. So that's part of the thing we're going to need to figure out here is straight across. So tell me what else we can do to this problem now. Okay, hold on a sec here. You're running away, May. Like, you take it away. Go for it. What did you say?
6 minus 1.5, and that'll be the side of the triangle.
Okay, so this side here, this is 1.5 tall because it's the same as this display case. This whole thing is 6, so overall then it must be 4.5 meters left, right? Yeah, we've got 90-degree angles in there. Okay, and this is also 4.5 meters.
And then you do 12 subtract 4.8.
12 subtract 4.8. How come?
Because of the top line, the hypotenuse.
Yeah, we don't know the bottom length yet, right? What are we looking for in this problem? Sometimes we can go crazy labeling and adding things.
2 minus 5.
Just a second, just a second. What are we looking for again? What are we trying to find?
Angle of depression.
So where would they be in this problem?
Top left corner.
The top corners, good. So right up
Yes,
here
top corners. Indeed.
and right up there.
Yes.
So can we find any of those right now with the
No, not yet. Oh wait. We can.
Really?
Yeah.
Okay, hands up if you think there's enough information right now to find it.
Oh wait.
Okay, hands up if you think we still have to keep labeling. All right, people who said that you can find it, yeah, you're correct. How come? Yeah, there's two sides of the right triangle there. So in this one here, this is my hypotenuse, and this is my adjacent. So the cosine, let's call this x. The cosine of x is the adjacent over the hypotenuse. So I'm going to have to use the cosine -1, the inverse cosine, in order to find that angle. And let's see what we end up with here. 20.36? Okay, I'll take your word for it. If you use Pythagoras, you could find the third side of the triangle, but I'm not sure that that's going to be helpful to us just yet, right? So here's the thing though, 20.4, is that the angle that we've got here in green, May, or is it the angle of depression? Because if this is the angle here, then the angle of depression is actually this spot right there.
Oh, so then you do the thingy.
Yeah, so it's going to be 90, right.
69.76.
Okay. So it should be 69.6 degrees. That is a 20.4. I will redo that then. 20.4. Okay, so I'm going to pause here. I'm going to let you guys go with this now. Now that we've tried one of them, with your neighbor, on your own, however you'd like, see if you can work out the angle on the right-hand side. And just remember, this is the angle in the triangle here, but the angle we're looking for is this one, the angle of depression, the one that goes down. It sounds like people at least have some strategies. Sine law.
Like that purple line could attach to that black line and then you have a triangle there.
Yeah, you have one side and one angle in that triangle. Unfortunately, we'd need 3 pieces.
The other side, would it be 7.2 meters away from the object?
Not quite, because 12 meters is the horizontal distance, and you're going on angles, right? Those lines won't be 12 because they're not horizontal. So what is the strategy? Did anybody... Sure, James, why don't you tell us about it? You made a triangle out of the whole thing? Okay, so you drew in the top piece? Okay. Oh, wow, okay, yeah. Okay, and the missing, sorry? Yeah. So just 1 second, you called this A in your problem? And then you use cosine law to find that one. Okay, let's try this, what James has suggested. It sounds good so far. So I've got A squared is 4.8 squared plus 12 squared minus 2 times 4.8 times 12 times the cosine of 69.6 degrees. So, James, what did you end up getting for A? 11.26? Okay. Yeah, now we could do sine law. We have enough pieces. We could also just use this right triangle here. We have 2 sides of a right triangle. We could do that too. So what do you guys want to do? You want to practice sine law or you want to do SOHCAHTOA? Sine law? Sure. Okay, so if we use sine law, we need things that are across from each other, and we definitely want this angle. So it's going to be these ones that are across from each other. And now that I figured out this angle and this side, it makes sense to use those two. Yeah, my picture probably should have been expanded up a little bit. What I will do for you is, why don't I redraw that triangle here? So this was 4.8, 11.26, and 12. And in the top here was 69.6 degrees. So if we're looking for this angle here, what I was saying is that we can use these pairs in the sine law. It's also possible to use cosine law in this question. SOHCAHTOA, you have a lot of freedom once you get that first piece started. So that's probably a good lesson for us all that, you know, it's not about getting the answer on your first shot, right? Just what can you find out about the problem? Take one step at a time, and now you have all kinds of options to answer it. So if I use sine law, I've got the sine, I guess I'll call this angle y. The sine of y over 4.8 will be the sine of 69.6 over 11.26. So there's definitely going to be a fair amount of calculations here. Sine of y is 4.8 times the sine of 69.6 over 11.26. And I'll put that in the calculator here. So I've got 4.8 times the sine of 69.6. And I'll just make sure my calculator's in the right mode. So for us, we should be in degrees. And divide that by 11.26. So I end up with about 0.4. So that means y is the inverse sine of 0.4. And there's no need to round it since it's still in my calculator. So it's the inverse sine of my answer, which is 24 degrees, 23.6. 23.5. It would round to 6, I believe. So, but yeah, 23.6 is the other angle for the camera. So here are two angles. This time I'm going to get you guys, see if you can set up the problem. We'll talk together, but just see if you can come up with a diagram on the next one. Can I move this down?
Yes.
Okay. Okay, so there's a picture there for you to work with. See if you can get everything labeled in and translate the problem down onto this picture. Did we see this in Victoria? I can't remember.
We saw a totem pole, but not that.
Beacon Hill Park.
No.
You feel so cheated now, don't you?
Well, thanks a lot.
It was carved from a single cedar log. Let's see here. Wants to determine the height. So I walked along the shadow totem pole, counted 42 paces. Well, you don't need to know the fact that it's the tallest totem pole, that it's in Beacon Hill, that Chief Mungo Martin did it, and let's walk through it again here, okay? So it tells us 42 meters is where he walked to in the shadow. Yeah, and he estimates the angle of elevation to be 40 degrees. And observe the shadow ran uphill and estimate that the angle with the hill is 5 degrees. So it's hard to see. Can you guys see that really? Well, I guess it's not that bad.
Wait, if the shadow was going uphill, doesn't mean the shadow would be smaller than the uphill?
Yeah, because the shadow's been cut off by the hill. Okay. So how can we work around this problem in order to figure out the height of the totem pole? I mean, a tape measure, yeah. Find what? AB, okay. So how can we start off then to find AB? Well, I'm gonna color code this triangle first of all. This one here, this red triangle I'm drawing in. That one's the one that's 40 degrees because it's harder to see there with all the stuff. Now, if you look at that red triangle, the only thing we know about it is 40 degrees, which is not enough to work with. There is a 90-degree angle there, yeah, you can kind of see it. Yeah, right here too. But here's the problem, right, is you only have the degrees, so there's nothing we can do yet with that triangle. We're going to look at the other triangle in this problem. I'll put a purple line in, let's see. That's not purple.
Can we find AB because there's a smaller triangle in it?
That's what we're going to attempt to do, but we can't get it directly.
Like, isn't AD and B a triangle?
ADB is another triangle. Yeah, we're going to probably end up having to use that as well. So, we want to keep building on that? You had a good idea there. I'm just going...
Can we do sine law?
Hang on, let me just...
5 degrees and 40
Let me draw the triangle in here that... Let's take a look and see what you think. Okay, this is the one... You have 40 degrees here, and you have 5 degrees here, and this one is 42 meters. So what do you think?
sine law.
Sine law? Will it work?
Yeah. Oh,
It will work.
yeah.
What's wrong?
We won't be able more than one side. We won't be able to find the right one.
No, we can do something pretty easy to figure out the sine law, right? Here's one of my pairs. This is the side that I want.
Yeah.
So how do I get this angle? Yeah, 180 minus 45. So here's the two pairs. 180 degrees in a triangle, and I've used 45, so 180 minus 45 is 135. Okay, so that means I can use sine law here. Sorry. We'll call this is side AB. So AB over the sine of 135 is equal to 42 over the sine of 40. All right, so let's take a look then. That's going to be, I don't know why it goes to sleep, but it's supposed to emulate a real TI-83, so a real TI-83 goes to sleep, so does this one. All right, so let's call that 38.2. When you do your calculations, you should keep those numbers in the calculators. The more you round, the more likely you are to find a mistake then when you get to your final answer. But let's label now in our picture. We know this is 38.2. So keep going with it then. Tell me what else I should do. Yeah. We've got 40 here, 90 there. Actually, we don't even need any more angles, but you're right. We could go 90 or 180 minus 90 minus 40. If you like, you can add 50 to the top angle here. How are you going to find the height, though? What are you going to do? Yeah, SOHCAHTOA. Whenever you have a right angle, you might as well use SOHCAHTOA. It's the easiest one, but it only works on right angles. So for the right angle here, The sides that I'm going to use, I have to use this one because that's the only one that I have a length on. So I have that side, and why don't I use the angle for 40? So these are my two pieces, which means I'm going to be using cosine because I have the hypotenuse, and I have the adjacent. So the cosine of 40 is the adjacent. You could use sine. You could use sine, but you'd have to use the angle 50 degrees up there to do sine, because 50 degrees is opposite. Yeah, it's fine. I'm not saying there's only one way to do it. I'm just saying my way has to use cosine because I chose these two sides in black. Over my hypotenuse, so I'll call it h. Oh, sorry. Is that what I think I know what you're talking about now. I need to wake up, right? Nobody, hang on a second. Oh, we don't need that side. We're looking for the height. Come on. There we go. So if we're looking for the height, which one should I be using?
50 degrees divided by 88.2, and then equals 40 degrees over h, I guess.
So you want to use sine law still, right? You can, but let's go so katoa. Which one is it? So, ka, or toa? Oh no. Ah, okay. It's this one here. Thank you, Joey. And what was the... Thank you. All right. Yeah, it's a tough Monday, too. There we go. Okay, this part, let me see if I can, hopefully I can redeem myself here. Tangent of 40 is the height of the totem pole over 46.2, opposite over adjacent. So the height is 46.2 times the tangent of 40. Now it is possible that you use the sine law to find that, but personally I think this is just going to be simpler because it'll simplify easier, right? That equation comes out quicker than I think sine law will. All right, let's see if I can at least do this part of it right. Tangent of 40. So 38.8. Move down here. Try another one. They're two triangles. So this one's actually kind of tricky because you have one triangle that's lying flat and one that's standing straight up. And it says these two people are planning on climbing to the top of this cliff and need to know buffalo jump. I'm going to assume that's when they used to run them off the cliff. Yeah, anyways, they need to know the height of the climb before they start. Starting at point B, so here's where they start. Determines the angle for ABC. Then estimates angle C, B, and D. And it says the angle between the base of the cliff and himself. So it looks like everything that was labeled in there. So here's the problem's asking us the height of this cliff. So I'm going to put a question mark there. That's what we're looking for. Now, let's... I'm not suggesting that this is the order that we use, but I'm just so that you guys can talk about these angles. Let's call that angle 1 and angle 2. I'll call this side 3. Let's call this 4, and I'll call this side 5. So out of all those numbers, what do you think we would want to find on our way to finding the height of this cliff? How come 5? Well, if you think about working backwards from this problem, why would 5 be a good one to have?
Because it has both triangles incorporated with it.
It'd be good to have. Okay. Well, what I see is when I look at the height here and I think, how could I find it? There's a 90-degree angle. Yeah. So I can use the tangent in order to figure that out. So that would be helpful to me. But how are we going to get there first? How on earth are we going to figure out the side length 5? Coleslaw where?
Sine law.
We could do cosine law, yeah. It looks like let's see here. Are we missing a side though? Yeah, we're missing a side. We need at least 2 sides for cosine law, right? Yeah. Sine law, I think, is where we should start here. So I'm going to have to erase some of this just because it's going to be hard to see. So here is the side that I want. That's one pair. Which other pair should I use?
The 50. Oh, 60. Because,
Well, we don't know that that's 90 degrees. What's this angle in here?
70. 180 minus 50.
Yeah, 180 minus, it'll give us 70 degrees.
So then we can use angle C.
That's right. So we can use these 2 sides. Okay? So let's do that to find that missing side. Let's call it x. So the length x over the sine of 50 is equal to 60. It's 70 degrees.
It's 48.9. Oh, sorry.
That's how we got 70.
Correct.
So if I rearrange this, x is 60, and hopefully I do it right this time, sine 50, sine 70. So let's 60 times the sine of 50 over the sine of 70. So you have 48.9.
Hey, I got it right.
So 48.9 is this missing side. It's not the height of the cliff, but it is getting us closer to that answer. So how can we use that again? Do you guys remember my suggestion? This is what we're trying to find, is this height.
Yeah.
So how are we going to do that now?
Yeah.
Right, SOHCAHTOA. You have a 90-degree angle. SOHCAHTOA is the easiest one in the group. That's why you usually learn it first. So it makes sense to make it up a SOHCAHTOA here. And if I look, I've got an angle, opposite and adjacent. So I can call this tangent 76 equals the height over 48.9. So the height is equal to 48.9 times the tangent of 76.
47.4.
Sure. So I'll just plug it in so that they can see how it goes in the calculator. Is that right? Okay, 196. Well, it certainly doesn't look that way in the picture. Let me make sure I'm in the right mode, and just in case my calculator switched over. No, I'm in the right mode.
One more time. Sometimes you just have to do it like instead of like all in the first, just choose it. Just do like 9.1.
The picture just isn't realistic.
No, it looks okay. Yeah, the picture I guess isn't very realistic. Well, the other thing you should think about here too, which would make more sense why it's so much bigger, is this is 76 degrees. That's pretty steep, right? So if it was 76 degrees, that's quite an angle to go up at 48.9 meters. So I think that's right, 196.2 meters.